So as people might know, we try to push like hacks to startups or to build products. And today we have the experience, unlikely you will build at one day like a really good product where you can make money with it. But if you keep building on it, long term, hopefully you will be successful, you become regular. And one guest of us who did this is Carina. She building Axiom, this super intelligence for math's proof. She raised 60 million. One of the investors was E14. And now we're trying to learn more about her. What is super cool about you? You also studied in Boston, so she knows the area. We're like very close from MIT. I think we have a couple of people from MIT or who's teaching or a student at MIT in the room. Okay, not too many. Well, a couple of 8, 9. Then let's please sit down and start.
This one?
Yes.
Would you mind if we record it?
It's being live streamed.
Yeah.
It's
Sorry.
on YouTube. Yeah.
Very live streaming.
Yeah, it's fine.
Yeah. Can you start out about telling about what Axiom Math's doing and what you're building?
Yeah. Hi everyone, I'm Carina, founder and CEO of Axiom. So I was actually here at MIT 2019 to 2022. I studied math and physics. So I remember I took some quantum classes. So the last talk was really, really interesting. I was remembering the homework exercises kind of like coming back in the last kind of board operations. So a lot of fun memories. Yeah, and then kind of went to Oxford, did this thing called computational neuroscience, which I didn't know in the UK is a code word for AI. So I was at UCL Gatsby, which is a really premium like AI hub with a lot of folks who kind of like look at neurodynamics, theoretical deep learning. I think back then kind of transformer made its kind of wave, and sort of like ChatGPT, a lot of people are talking about it and kind of look into, okay, what if you have like a one layer linear transformer, like how can you analyze the neurodynamics, which turns out to be quite hard. Then went to Stanford, kind of my second year, dropped out, started this company, and now we're about 20 people, trending 25, and we kind of were founded July 15th last year, so about 7 months ago, the day of the International Maths Olympiad, starting day, I remember. And then since then we have, I think executed on a pretty fast pace. We have our AI Axiom Prover solve the Putnam exam 2025, which is the hardest undergrad math competition. And by solve, I mean it got a perfect score. So in the Putnam exam history since 1927, which is 98 years, there are 5 human perfect scorers ever, and the 6th perfect score comes from an AI system completely end to end without human intervention in real time of the exam. So it's not a benchmark. And then about 2 months later than that, so it was like a couple of weeks ago, we just announced that Axiom Prover actually cracked like a batch of research conjectures in math. So that includes Fell's conjecture, all numerical semigroups. That includes partial Vandenberg conjecture, which is the conjecture in algebraic number theory relating to class groups, and talk a bit about that. We also crack a lot of problems that mathematicians from around the world send us, such as Stephen Miller, who's a Williams College professor, runs a small RU, one of the best math undergrad research program. He has this kind of discrete math like combinatorial probability kind of intersection conjecture, and then we solve it called dead ends and square free walks. There's the other one from Professor Dawei Chen, who's actually Boston College, also Boston loco, who's an algebraic geometer, and he has this conjecture about the parity of the differentials of genus surface of genus 0 and 1, and then we also solve that. By we mean really the AI. We did no work, we just let it run, and it just solved it from the natural language problem with sort of no human intervention, and the output is thousands of lines of Lean code. Lean is this sort of programming language for proof, but in addition to being a programming language, it also is a protocol that verifies. So in the computer science analogies, both the C language and the GCC compiler. So there's this kind of really beautiful concept called the Carter-Howard correspondence, which describes the idea that you can have proof as computer programs. So for a mathematical proof that you write, you can turn that into a Lean proof and then execute it like you would execute any computer program. You're gonna either get a check mark telling you congratulations, it's successful, or hi, here's an error message, please fix it. A bit similar to what you would expect in say any other programming language. You can also write an autograd in Lean. It's actually quite functional as just a programming language. It doesn't having nothing to do with math. So it's kind of flexible in that way. It can represent code and also represent math and logic. yeah, so I think that's kind of like a very brief overview of Axiom. We are building a super intelligent reasoner that's hopefully self-improving. That includes that it should self-verify, and it should generate new knowledge. And as its capability increase, it should be able to challenge itself to discover new things. So you will discover some patterns, and then you will conjecture, form a hypothesis, and then the same system will try to solve that hypothesis. We expect that to be a self-improving loop. And we're going to start with an AI mathematician and extend to other things such as, chip design, chip verification, code generation, code verification, and other things such as cryptography and engineering sector.
Kind of already answered most of my questions.
Oh, okay.
But it's really nice. So yeah, my first thing when I was reading it, I thought it's like crazy cool, but it sounded for me like a research project. Do you then have like a business side, or how do you make money at the end, or what is the plan?
So there's this like interesting sort of article in Wall Street Journal called Neolabs Race Billions. It's kind of describe this phenomenon right now that there are like a bunch of research, fundamental research companies, frontier AI labs that are called Neolabs, and the description is exactly that. At the very start of the startup, the success or not depends on the innovation and the R&D side of the company rather than the business side. So instead of kind of like crunching revenue numbers, people are training models, and that's incredibly cool. I think from a hiring perspective, I think if when I was considering whether to do a PhD or not, if I knew that such a company exists, like very small, like 10, 20, 30 people with large amount of compute resources, like we're looking at 4-digit, like H200s available, 24/7. I would probably consider that to be quite an appealing option as opposed to say, doing a PhD in academia, even though obviously you learn from world-class professors and universities, but you also like learn a lot from a lot of industry veterans, such as people from OpenAI, Anthropic, Google DeepMind, and Meta Fair, these sort of frontier labs. A lot of the people who currently are Axiom, over half of it, actually majority, are from Meta Fair, so Meta superintelligence labs. So I think there, it's not just one of us; there's like a group, and in terms of like the sort of business side, I think it's important to pick like a frontier research problem that also has very clear and in a way short kind of commercial pathway. So from our perspective, we think verification is the best first market. We think that you can actually something that we realize is that it is a lot harder to have your AI solve Putnam at a perfect score than to verify hardware. Verifying hardware actually involves a lot of like detail checking and like sort of bookkeeping, like casework, versus like sometimes the Putnam exam, especially last problem, requires you to like have like a leap, and then that creativity leap, the eureka moment, is actually quite hard to replicate. So I think like for us, we're in a kind of lucky position that there is a very sort of direct like commercialization opportunity, and then there are customer inbounds. For other new labs, it might be a different situation, but also maybe they have like more high profile founders such as Mirati. But
yeah, that sounds amazing. One question I had is more like a personal question. So I also actually tried to raise money for a research lab. And then the problem you often face is that you need to raise a lot, like 50, 100 millions, or like for the AI lab, sometimes a couple of 100 millions. What do you do that like VCs take you serious? If you go there and then you say you want 60 million and they don't trust law of you, they think you have a good plan. What can you have there?
Yeah, I think there are a few like examples that we have heard from some of the most legendary founders about setbacks, especially setbacks during the fundraising process. There's this famous example of the Menace founder cried, like squatting on the street and cried right after he got rejected from a VC office. That's pretty brutal. Now Menace has this like $1 billion acquisition to Meta, a very successful exit, arguably. There are other very high-profile people who failed to raise money, like people who have been leading, I think, industry frontier labs. I think that is always like, expect that to be challenging and just keep going. I think sometimes like life is like that, which is like similar to when you take a really, really hard like quantum physics class. Sometimes you're just like, you can only expect it to hopefully get better. But practically, I think one is like probably I wish I was a bit more prepared when I was starting those round of basic conversations. that will probably make my process a lot faster. That's one thing I think I, in retrospect, would have done better. The other thing I would have probably done better is I would probably assemble a larger team. I think when I started talking to people, there was like the number of people were like one or two or three. And like, or meaning like there are people who are not in the US, so it takes them months to leave their job. So it's not a, they haven't officially joined yet because in certain European countries, kind of, if you want to leave a job, you need to give like how many months notice. And so like that's another thing. It's like, probably have more stuff, like including team composition, including probably write out your technical memo. Another thing I wish I've done better is like I wish I have been more like open to share more about what we were doing. I was like always very like not trusting, like, I think like information might leak. Turns out ideas are really cheap and it's just all about execution. I mean, unless you're like having some really groundbreaking idea. And in this case, I think when we were starting out, AI for math was pretty much a very niche thing. Axiom was like, born out of a time where there were very, very few people seriously doing it, and most of these people are in academia. Google DeepMind has kind of switched from formal to informal. OpenAI has publicly said they believe only in informal. And so for us to be like, hey, we're a formal math startup and we're gonna beat all the informal frontier labs out there, is a pretty bold statement. I think now people kind of like are more and more like receptive to that idea. So I think that's kind of, very interesting timing.
Yeah.
And I do think one thing that's interesting is perhaps there's something I also have learned later is like you might want to let others price you rather than say how much I want to raise. That's like another thing, which is like sometimes as a first time founder, my estimate of how much it will take for me to reach the next milestone is totally off. Like, in retrospect, I have totally over raised for my first round because it took us like very short amount of time to get to the next proof point, and we have another round going right now. So I like, maybe at some points having trusted mentors that are not exactly the VC directly negotiating with you, that will be helpful. And maybe you can also let the market kind of price.
Okay, last question from me, and then I want to open it to the audience. So when you talked to VCs at the time, you already had like an MVP, or like it was more like an idea, and you had like these professor names on your site for like credentials.
Yeah, I think so. What we had was a very sort of so one is our vision was about the time where a few venture firms have internal memos, seeing that this is going to be the future. So this is something, and they're waiting for a company because they didn't find the other player existing back then to be the natural bet. So they're kind of waiting for like a team that comes and say, hey, it's not just about Olympiad mass benchmark. It's about research, conjectures, and scientific discovery. Hey, it's not just about formal proving. It's about auto formalization, which is bridging between informal natural language specification to formal specifications. It's not just about functioning within the formal space using very compelling techniques like Monte Carlo tree search. You can explore more things. You can like leverage the strengths of informal system. So I think there are a lot of these sort of like theses that are like that have been waiting for quite some time. I think we arguably have a very strong team. So I think the CTO Shubo is a fair director. Facebook AI research, and there are a lot of other teams coming from fair infra, compilers, cryptography, and I think it really was not very. It was a very risky and high conviction bet. I think in hindsight, but I think now that have been proven a little bit more.
Yeah, awesome. Now we can ask questions from the audience. Yeah, Jason.
Hi.
Thank you for the wonderful talk. My question is kind of around the verification that you were talking about. It seems like verification is the thing that's separating, AI from dominating the humans, pretty much. So, how impactful is this verification that you've been able to crack, and how has it impacted your own learning? Like, how do you feel as a professional expert now working with an AI that can verify results? Where do you stand in the loop?
Yeah. Thank you so much. This is a very good question. One thing that we recently discovered, which I don't think the world necessarily knows yet, is that the Putnam solving AI prover, the Axiom prover, with no modification whatsoever, saturated a code verification benchmark, 99%. So that code verification benchmark is called Carina. It's developed by Meta and Berkeley researchers, and there are about like 189 problems, programming exercise type of problems, and we were able to generate code with proof at 98.93%, and that shows some sort of transfer learning from the math, like proving to the code software verification. I think you're right that like in a lot of the mission critical domains, basically just if you talk about AI in like Aero Astro or like SpaceX, it's like there's a lot of risk about like whether all the edge cases will be covered in cars too, like safety critical domains. In some less mission critical domains, validation by human remain a bottleneck. Specifically, we now have pretty good vibe coding for lovable websites, but like it's very far from vibe coding a control flow or vibe coding a nuclear reactor.
There
I
are people
think
who
that's-
disagree with you.
Yeah. So that's quite hard, and I think that what we are trying to do at least is to bring the logic element, in the because you have like output generated by a computer program, and like output needs to be affiliated with a property for it to make a lot of sense, and that property sometimes comes from proof. So I think like we believe that verification and verified AI is the next frontier, and we are hoping to be a complementary component to the code generation products. On some other domains where the code generation is just lagging, like say hardware, then we want to maybe have standalone, ID.
Yeah. Good. Let's do 2 more questions. Andrew, please.
How did you go and build the initial team? Did you have like a team going into like the raise initially? Because it sounds like you had a very strong team off out of the gate.
Yeah.
For that, how did you go and assemble that team?
It-
Like convince them to join on.
Right. I think it was like gradual. So like every wave is like 2 or 3 more people. So it's not like everyone at once, but it's also not like it was only me. So it's like a wave. And I think there are like interesting timings, right? Like I think like we somehow are very we take recruiting at the highest priority honestly ever. So there are a lot of relationship building with frontier lab researchers that are just going on when they are still very happy at wherever they are, and then one day if they're unhappy they remember to call you first. And so like because I think it's just like a very fragile kind of like tech market right now among the big labs. There are like all sorts of mergers, like layoffs, not necessarily someone who are impacted by the layoff, but like say their best friends got laid off, like they're not very happy and motivated. And there are a lot of these sort of amazing, incredible talent who yearn for a harder problem and for like that hard problem's focus time to be a little longer than a quarter's performance review, right? So like at Axiom, you can have that like peace of mind that what you're working on is gonna be the long-term strategic focus of the company for like 2 years. Like that's incredibly long compared to like anywhere else. So I think that's probably one of the point. And a lot of people really have this belief that they want to have like software engineers enjoy the luxury of mathematicians who have been vibe coding for like in English for centuries. Like mathematicians have a pen and a paper, and they have been really vibe coding logical reasoning for the past like thousands of years. And this is not the status now of a software engineer, and especially not that engineer who's doing chip verification or like formalizing like a hypervisor that took them like 3 years and 260,000 lines of serial improving code. So like I think that it's like another thing that a lot of people really have that dream.
You had a question, and then Artem last one.
Yeah, so like if you want to get into like research labs or you want to get into superintelligence and all this upcoming like fields, like how do you recommend like to enter these fields? Like what steps should we take?
Yeah, I think one I always say is like the open source community is a really good place to start with. Some of our really high value hires come from industry, but some other ones come from open source community. They sometimes put their writing and their project out there, and I spent my entire Christmas to New Year like that, about 2 weeks time, reading like every single word like one person has written like ever. And there are many blogs. Geez, it was a very, but like I think that is like a very good way to get involved. The other thing is I think like the fundamentals. I know we're in a time where AI has been assisting more and more like coding and stuff, right? So then ML design, system design becomes more important. So I think just these two.
Like do you need a PhD or
Joining
like,
hackathons.
Huh?
Joining hacks. Like what he does today. Perfect.
Yeah.
Like,
Um,
do you need any PhD or grad school for
Not
these kind of
necessarily. No, we have undergrad, we have PhDs, and I think other places too.
Thank you so much.
The one thing I would say is if you're in the PhD, still practice the industry strengths code that you used to write in undergrad. That's I think one thing that's probably important to like just keep up.
And join a lot of hacks like today.
Yeah.
That's the best thing you can do. And our last question.
I'm curious. Yeah, thanks a lot for the talk. I think it's very inspiring. And I'm curious. Like now we see lots of saturation of pretty much all the benchmarks everywhere.
Yeah.
Like, how do you measure? Like, what are your benchmarks?
Yeah.
I'm particularly interested like what you think about HLE.
Yeah.
Is it a good benchmark or not for you?
Right.
And then also maybe like a second part of my question. Are you purchasing any data or like are you collaborating with any other?
Yeah, I'm so excited to jump into the technical things. I also like welcome more technical questions. We'd love to tell you about more like Axiom technology, you know, in addition to the fundraising aspect. So one on benchmark, we are living in a world. For us, it was a very very annoying situation where we basically don't have much more benchmarks currently. We have saturated mini F2F within the first 2 months. I mean, we spent 1 month building infrastructure. Second month, we saturated mini F2F, which is high school math Olympiad math benchmark. Okay, now you have something called Putnam Bench. And instead of Putnam Bench, we chose to participate in real time for Putnam. In the older years, like Putnam Bench problems are a lot easier than Putnam. And we kind of calculated it took us about like quite a lot of money if we want to run that for Wave. So we just didn't do it because we know we can do Putnam pretty consistently, correctly. We did some recent years. And so that's undergrad. And then now there isn't actually a PhD level formal math benchmark that cover all the domains. There's a series of benchmark called FATE, F-A-T-E, all cap. FATE, I think N, FATE N, FATE X, FATE H, different kind of levels, and they only cover like algebra, like you know, there's like no analysis, quals, like PhD exam questions in there. So we don't have like PhD level, like, and there's frontier math, of course, but frontier math, like you know, none of the first of all, they don't tell you what this is. Only OpenAI has it. The other thing is like it's only in one numerical answer. Like they don't give you the proof, and they also like select problems that have a numerical answer, which is not representative of field mathematics at all. Like things like adult math or research math usually are proof based. So we kind of are urgently assembling benchmarks that are at PhD and junior research and senior research like levels. Currently this benchmark we have an email, and this email are being flooded by mathematicians around the world with their requests of whatever they are currently solving, and probably their grad students don't know how to solve. So and you know, we will have our in-house mathematician take a first pass, and they usually can't solve it. So then Axiom Proof will try to do it. But that's like very ad hoc, right? It's not like it's not here's 600 problems. We got like past one, like how many? Like it's just difficult. So that's one. And on the
actually, like is it any good? Like they claim to be PhD level.
Humanity less exam.
humanity less, and no HLE, but like the HLE problem is like it's not just all math, right? It's a lot of
There's subset.
right, and that I mean we haven't, it wasn't like a lot, so we kind of thought of HLE as like more like there's some unverified stuff as well, as in like you know it's factual but humanities, social science kind of stuff. So we didn't really think too much about it. We will look into it probably after this talk now. And then on the code verification thing, after Verina being saturated, we don't have another good code verification benchmark. There's one called Clever, CLEVR, literally Clever by UT Austin. That one, some of the researchers don't like it for some of the designs. So when researchers don't like it, Axiom is really a place where researchers rule. They don't want to run the eval on it. So yeah, if you have a benchmark, make sure the researchers generally like it. Otherwise, they will not eval their system on it. And on data, data is one of our kind of differentiated bets. Is we believe in large scale automated data generation. Not quite synthetic because it's all verifiable, right? You can now verify whether the proof you have generated actually solved the problem, which is quite powerful in our domain. Before we started, there are less than 2-digit million, so like 10 to 15 million tokens of mean data out there, say on Mathlib. We have now a proprietary data set of a large, much orders of magnitude larger. By the end of the year, we'll hit 1 million times larger than that, which is still not 1 trillion in terms of, say, the token count for Python. But that cannot be done by just having human like experts like label it. So it's currently a combination of auto formalization, which is converting informal to formal, or within from however amount of formal data you have to make 100, 1,000 times high quality variance, not just semantic kind of like perturbation, but you do things like fuzzing, you do things like repair, a lot of the more kind of like compilers, like codegen, like way of looking at
Yes, please.
Yes. What's our some long-term architectural bets that you're taking?
This is a little bit trying to figure out what the right detail to share. Yeah.
Non-confidential.
So we believe.
Or maybe like things that you
Yeah.
be outside of Axiom.
Yeah, so I will talk about a few things that I think currently we're ahead of the curve. One is this idea of scaling learning from experiences. So I don't know if how many of you have read the Anthropic blog on sub-agents and skills. There's a lot of alpha there. I think this is underexplored. I think we currently have seen the data trail of attacking a really hard research problem and the tree graph that comes out of it scaling almost indefinitely, and sky is the limit. So an easy Putnam problem can be under 40 nodes. That's a decomposition tree. We have runs where it's 4,000 nodes, much deeper and much wider trees, and scaling inference. So that's one thing that does scale. And then the second point, which I will kind of come back to the first point after I talk about the second point, is we have a dozen deterministic tooling that are written for lean in lean. So the reason of their existence is to generate things and verify things in lean faster and more robust, in a more robust way, hopefully with cheaper costs. So anything that these tooling can do, you don't need to pass through like the model that has like LLM and like to do it, right? And these dozen of prover tools, we rebranded them as Axle, AXLE, Axiom Lean Engine. Good news is they're coming out at the beginning of March. So all the about 12, 13 prover tools are gonna be publicly served on API for free for researchers. Will require sign up, but that's it. And that is really powerful because we believe in this like combination of not just deterministic tooling, but also like deterministic tooling written in that native language. And then there's like the comeback to the first point is after you have these tooling, and of course you have your like system of like really strong post-trained models, you then can like explore what a skill is like. A skill is learning to apply a combination of these tools. And then so you have a bunch of sub-agents tackling the sub-goals of your problem in a very recursively decomposing way and learn to backtrack. And that I think when the magic starts to come together. Some of the longer term bets we are taking are, one is a self-improving aspect of it. Every time it proves something, it will feed back to the system. So it's not like the Axiom prover is trained on say like, the knowledge cut off today. It will continuously self-improve. It will have seen more things that it, as a superhuman mathematician already, has proven. The other bet that we are taking is bolder data bets. We want to have the words, every archive paper, every journal paper, everything that's math on the informal space being converted to lean, and we want a knowledge graph of that. We want to understand how that structures that, and we want to learn to conjecture based on that. So the third bet is actually conjecturing, which is the important part, again, on the self-improving loop, is that how can I give reward to my conjecture? So yeah, we're hiring, and hiring is really, really easy, like in terms of like, as in, like, for
at the end,
candidates.
you want to,
Yeah,
how
yeah,
can we
yeah.
help you? You want to, or can people use your product?
Yeah, so it's I mean, like like if you're considering industry opportunity, potentially consider us for your internship or full-time opportunity. It's careers@axioms.ai, and Shubo, who's the CTO, and I, we look at every application ourselves. So we don't have any agency, whatever. It's Shubo at the start, me at the end, in the middle. It's like all the technical ICs doing the interviews. Yeah.